Hey everyone, Morgan here. So we're in the Acids and Bases unit, Honors Chemistry, page 9 of the lecture outline. And we are talking about acid-base neutralization, which is going to be leading us into a whole big discussion about titrations. So the question becomes, what happens when we mix an acid and a base? Well, they react and you get water and a salt. And that salt will change depending upon what acid and what base you are reacting. So imagine HCl and NaOH to give you H2O and NaCl. And everybody wants to know, can I drink that? It's just salt and water. The answer is no. There's a lot of other impurities that might be involved with the HCl and the NaOH. You don't know if it's completely neutralized. You could have excess reactant, HCl or NaOH. And even if it is a perfect titration, you will have used an indicator to tell you when it was done, and there's another potential poison right there. So we don't drink anything in the lab. So how much of each reactant would we need to mix so that the resulting solution was neutral, a pH of 7? The answer there is an equal number of moles of acid and base. They must be perfectly equal. And we know that the molarity of an acid or base solution can be calculated using the formula moles over liters. And then if we want to solve that for moles, it equals molarity times volume. So since the idea is the moles of the acid must be equal to the moles of the base, the molarity of the acid times the volume of the acid must equal the molarity of the base times the volume of the base. Often people just simplify this as C1V1 equals C2V2. But I think this is a much more intuitive equation because it tells you, which one's the acid, which one is the base. So this is often called the dilution formula back in earlier chapters. It's the same idea here, that the moles of one has to equal the moles of the other. Okay, so how much 2.00 molar HCl would be needed to neutralize 42 milliliters of 1.50 molar NaOH? This is a 1-to-1 ratio, and that's important to know. Okay, so concentration acid equals concentration base. Volume of the acid is going to equal the concentration of the base. Volume of the base over the concentration of the acid. Now it's 1.50 molar NaOH times 42.0 milliliters of it divided by 2.00 molar HCl. Molar cancels molar, and I come up with something in milliliters. And I got 31.5 when I ran that through my calculator. Okay? Very reasonable answer here. Now in this next question, we're still reacting HCl with NaOH, so again, it's a 1-to-1 ratio, which is good. How many milliliters of HCl are needed to completely react with 25 milliliters of 0.5 molar NaOH? Okay, so again, concentration acid, volume acid is equal to concentration base, volume of base, or the volume of the acid is Cb Vb over Ca. Now the concentration of the base is 0.50 molar times 25.0 milliliters over 0.50 molar. The molars once again cancel, and isn't that interesting? That's 25.0 milliliters. Okay, pretty straightforward as long as the ratio is 1-to-1. So now, how about when I'm reacting H2SO4 and KOH, which would give me K2SO4 and H2O, and I'd have to put a 2 there and a 2 there. This is now a 2-to-1 ratio. Okay, I need twice as much base to react with the acid. I can still do this as kind of a CAVA equals CBVB if I wanted to. Okay, and then the concentration of the base would equal the concentration of the acid times the volume of the acid divided by the volume of the base. Now, I have 36.0 milliliters of 0.250 molar H2SO4 times 36.0 milliliters of it, and I'm dividing that by the neutralized 25 milliliters. There it is. There's my volume, 25.0 milliliters of the NaOH. The milliliters cancels. This equals 0.36 molar, except because it's a 2-to-1 ratio, it must be twice that concentration, which means it's going to be 0.72 molar KOH. And there's a few different ways stoichiometrically that we can deal with that. Okay, when we come back to the next page, it's all about the lab procedures involving titration. Thanks for tuning in.